You know, let's talk about something you've probably seen 1,000 times, but maybe never really thought about. It's a story about huge metal structures, a relentless enemy, and a tiny, unsung hero that makes an incredible sacrifice.
I mean, seriously, think about it. A giant iron ship floating its entire life in salt water. That's like the perfect recipe for rust. So why doesn't it just dissolve into a cloud of orange dust and sink to the bottom? Well, the answer isn't just clever, it's one of the most elegant and frankly coolest solutions in all of engineering.
So before we get to the solution, you really have to respect the problem. For any ship out there, its greatest enemy isn't some mythical sea monster or even a hurricane. No, it's something way more patient and way more destructive: rust. It's like this silent, chemical predator that never, ever sleeps, just working to dissolve that iron hull molecule by molecule every single second of every single day.
So how in the world do you fight an enemy like that? You might think the answer is, I don't know, just a really good coat of paint. And yeah, sure, that's definitely part of it. But the real defense, the secret weapon that guards the very heart of the ship, is something else entirely. It's a strategy that feels like it's pulled not from an engineering textbook, but straight out of a spy thriller.
That's right. You don't just shield the ship, you give it a bodyguard, a dedicated protector whose only job is to step in front of the bullet so the ship doesn't have to.
Now, of course, science has a name for this bodyguard. It's called sacrificial protection, and honestly, it is every bit as dramatic as it sounds. The whole strategy is brilliantly simple. You find a metal that's even more willing to corrode than iron is, and you bolt it right onto the hull. You're basically offering the enemy a much more tempting target.
Oh, okay, but how? How can one piece of metal basically tell the ocean, hey, go after me, not the ship? It kind of seems like magic, but it's actually just a beautiful, fundamental law of chemistry in action. Let's break down how this sacrifice is actually made.
Okay, so here's what engineers do. They attach these blocks of a more reactive metal, let's use zinc as our hero for this story, directly onto the iron hull. Now in the big electrochemical battle that we call rust, salt water is the battlefield. And because zinc is more chemically eager to react than iron, it essentially volunteers to be what's called the anode. Just think of the anode as the designated loser in this chemical duel. All those corrosive forces in the salt water just pounce on the zinc, eating it away, and leaving the iron hull completely untouched and unharmed.
And this really lays it all out, nice and simple. On one side, you've got zinc. That's our hero, the bodyguard. It's more reactive, which means it bravely throws itself in front of that chemical attack. And on the other side, you've got the iron hull. It's less reactive, so nature's corrosive forces just pass it by, focusing all their energy on that piece of zinc instead. The bodyguard takes the fall, and the asset stays safe. It's that simple.
You know, it's so easy to see this as just some clever engineering trick. But if you zoom in, like right down to the molecular level, what's happening is genuinely profound. There's this silent, invisible drama playing out on the hull of every single ship at sea.
And I want to be clear, the key word here is literally. This isn't just some cute metaphor we made up to make it sound cool. The zinc is physically dissolving atom by atom. It is giving itself up so that the iron hull can stay intact. It is actively being destroyed to make sure the ship survives.
Our source material really sums it up perfectly, calling it the ultimate act of chemical bravery. And that's exactly what it is, isn't it? It's one element sacrificing itself for another, simply because the fundamental laws of nature demand it.
So let's just take a moment to appreciate the sheer elegance of this whole thing. We're not fighting nature with brute force here. We're not trying to overpower it. Instead, we're using nature's own rules against itself. It's kind of like a form of chemical jujitsu.
And that's really the big idea to take away from all this. Just by understanding one simple rule, that the more reactive metal always goes first, we solved a multi-billion-dollar industrial problem. And this bodyguard principle isn't just for ships either. It's the silent guardian for underground pipelines, for the steel skeletons of bridges, and for the legs of offshore oil rigs. It's a perfect example of humanity at its absolute cleverest, using a deep understanding of the world to get a simple, powerful result.
Which kind of leaves us with one last thought. This chemical bodyguard is on duty all around us, in places we've probably never even thought to look. So from now on, when you see a big metal structure standing strong against the elements, a bridge, a pipeline marker, maybe even your own water heater, ask yourself, is there a hidden hero attached to that somewhere, silently sacrificing itself to keep it standing?